Hello, everyone. Welcome to Simplifying Radicals. So we're going to be doing square roots and cube roots. So at some point, most of you have seen square roots before, and you've never had a number out here before, unless you've seen cube roots. Then you see a 3. So when you do square roots, there's an understood 2. No one ever writes the 2. It's kind of like when you write x, it's understood that means x to the first power, right? We don't write the exponent. We know that it's there, and we've done that recently. All right, so square root of 81. So we're looking for two things, two of the same things that make 81. Well, since 9 times 9 makes 81, the square root of 81 is 9. That's a fairly common one. Here's one you're not going to see very often, square root of 484. Well, that's 22 times 22. So the square root of 484 is 22. Right? So square root of 84. Well, I can rewrite 64 as 8 times 8. Right? So 2 eighths makes 64. So the square root of 64 is 1/8. This idea where when you're taking the square root, again, there's an understood 2 there. It takes two of the same underneath the radical to make one outside the radical. Like over here, the square root of 4. Well, 4 is 2 2's. You're probably not going to write it out this way until we start coming down here. Right? So the square root of 4, let's change that color. That's a little dark. So the square root of 4 is the same thing as the square root of 2 times 2. It's just written differently. And now, either way, whether you say the square root of 4 or the square root of 2 times 2, you get 2. So this is equal to 18 times 2, which makes 36. When you do fractions, you can think of them as separate. Instead of thinking of this as the square root of 1/16, it's the same as if you think of it as the square root of 1 over the square root of 16. Square root of 1 is 1. Square root of 16, well, it takes two 4's to make 16. 4 times 4. So the square root of 16 is 4. Same thing here, split it up. Think of that as the square root of 9 over the square root of 100. Well, 9 is 3 times 3. It's two 3's. So you get 1 3. Square root of 100, 10. Okay, so when they're perfect square roots, doesn't take too much time. When they're not perfect square roots, like this is not a whole number answer. It's almost 5, right? Square root of 25 is 5. That's a little bit less than the square root of 25. So that's going to, so when we, if you plugged it into Desmos and you got a decimal answer, you're going to get something a little bit less than 5, like 4.9 something. Okay? But we don't want a decimal answer. We don't want a rounded number. This square root of 24 is a decimal that keeps going forever. It's one of those irrational numbers like pi. You guys know pi, 3.1415 dot, 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 keeps going forever, never repeats a pattern. What we want to do is, this is called simplifying. We want to simplify. And the best way that I've found for students to learn this is to break down the 24. Okay. To a factorization, factor tree. So take 24 and think of two numbers you can multiply that makes 24, right? So some of you might be thinking 2 times 12, 4 times 6, 8 times 3. You got to pick one of those, right? You don't use 1 times 24 because then you still got a 24. Then you're like that dog chasing his tail. You're not getting anywhere at all. So we're going to split this up somehow. I'm going to pick 2 times 12. 2 times 12. Now, can I break down the 2 anymore? Well, I could do 1 times 2, but again, then you still have a 2, and you're like that dog chasing his tail. So I'm going to stop here. I'm going to circle it. Some people like to underline it, but everywhere that I stop or I can't go any further, I'm going to mark it somehow. All right, the 12 I can split up. And again, I'm not going to write 1 times 12 because I still have a 12. I need to break that up. So some of you are going to want to do 2 times 6. Some of you are going to want to do 3 times 4. Pick one of them. It doesn't matter which one. I'm going to do 3 times 4. So 3 times 4. I can't break down the 3. So these places where I'm stopping, this 2, that's because that's a prime number. I can't break up 2. 3 is a prime number. I can't break it up. I stop there. Well, the 4 can be broken up. It's not a prime number. It's what's called a composite number. The only way you split up 4 is 2 times 2. We've already figured out that 2 can't be broken up. So the other benefit of circling these things or marking them somehow, it's clear which numbers you're going to use for your next step. All these places where I had to stop, these are the numbers I'm going to use. So I have a 2, a 2, a 3, and a 2. Well, I like to do things in order. I have 3 2s, a 2, a 2, a 2, and then a 3. So 2, 2, 2, 3. Now we're still taking the square root of, and this is still 24. It's just 24 broken down into its prime parts. So what you want to do now is look for pairs, right? Because if you pick this pair of 2s, that's just 4. And the square root of 4, right? 2 times 2 is 4. Square root of 4 is 2. So basically it takes 2 on the inside to make 1 on the outside. Now these guys don't have a partner. They have to stay put. And at the end, you want to go ahead and clean things up. So multiply your 2 and 3 together, and you get 2 times the square root of 6. Now, the way to check to see if your answer is probably right, and I can't guarantee that it's right because you may not have simplified it completely, but what you do is you can plug both of these, the original question, and then your answer, put them both in a calculator, Desmos or whatever, and they should give you the same decimal answer, okay? If the question and your answer, when you're simplifying square roots, if the question and the answer don't give you the same value, then they're not equal, then you haven't done it correctly. Because when you simplify something, they're still equal. Example, when you simplify 4/8, you get 1/2. But 1/2 is the same thing as 4/8. Both of these will give you 0.5 as a decimal, all right? Same idea here when you simplify a square root, they're still equal. They just look different, just like these two fractions are equal, but they look very different. All right, let's try square root of 48. Same concept. Let's take that 48. It's not a perfect square. It's almost is, right? 49. Square root of 49 would be 7. So I know this number is really close to 7, but it's not 7. So I need to break this down. I need to split up 48. And again, don't use 1 times 48 because then you still got 48. Okay, you just don't use 1 when you do your factor tree. I can use 2 and 24, 6 and 8, and there's a couple of others I could use, right? I'm going to go with 6 and 8. Starting point doesn't matter as long as you pick a pair that multiplies to equal 48. Now I've got to pick a pair of numbers that I can multiply to make 6. Well, there's only one pair there, 2 times 3. I can't break up the 2. We've already discovered that over here. And I can't break up the 3. Again, we discovered that over here. Now the 8. Only one way to split up the 8. 2 times 4. I have to stop with the 2, but this 4, I can make that into 2 times 2. All right, so now I've got a bunch of 2's, right? And again, because I circle all of my prime places, all my numbers where I have to stop, it's easy to see what numbers to use for the next step. Got 1, 2, 3, 4 2's and a 3. So 1, 2, 3, 4 2's and a 3. Okay. What's circled goes under the square root. Now you look for pairs because a square root, you're looking for 2 numbers, looking for pairs. So that comes outside, that becomes a 2. But look, I've got another pair. That becomes a 2. And this 3 does not have a partner. It has to stay put. Now, what do you think I'm going to do with these 2's? Well, everything up here was multiplication, right? So, of course, it's going to remain multiplication. And so now I get 4 square roots of 3. Okay. Let's do 175. All right. 175 ends in a 5. So I'm pretty sure that 5 goes into it, right? If it ends in a 5 or 0, I know I can do 5 times something. And that's going to be 5 times 35. Can I break up the 5 any? Nope. All I can do is 5 times 1, so I'm done there. 35. What can I multiply to make 35? Well, there's only one way to do that. 5 times 7. We've already established we can't split up the 5. I know 7 can't be split up. So I've got nothing else that needs to break down. So again, my circled values are what's going to go in here. So I've got 2 5's and a 7. So again, when you take square roots, remember there's an understood 2 there. So I'm looking for pairs. I'm looking for groups of 2. So a couple of 5's inside. I bring 1 5 outside. 7 doesn't have a partner. It is going to stay put. 5 square root of 7. Again, if you type square root of 175 and you get a decimal answer, this needs to give you the same decimal answer. If it doesn't, you have done something wrong, right? So I am going to stop right there, and we will continue this on the next video.